Hello, in this video we're going to continue our work with sampling distributions, or the distribution of random samples. Instead of looking at means, we're going to look at proportions. So some things are a little similar, some things are a little different. So when we looked at the number of piercings and we did this experiment with drawing random samples, that was quantitative data. And we took a sample and we averaged together and we got a sample mean. Okay, this time, instead of quantitative data, we're going to use categorical or qualitative data. Now, it has to be a yes-no question for this to work. And so we're looking at categorical yes-no data. Okay, so I'm going to do another another experiment. And I'm simulating one that we did in an actual stats class. I had the data from a previous class, but now we're under quarantine for COVID, so I'm recreating that experiment. So what we did was, first we made a statistical question to ask everyone. So this time we're doing a survey. Instead of using a previous class data, we made a survey question that was yes, no, and the question that the class decided on is, were you born in Oregon? Okay, so it can't be something that where you could say like, well, maybe you kind of have to be born in one state or one country or not, right? So this works for our categorical yes-no data. And this time you're not going to see the distribution before, so it's going to be kind of interesting to see how this goes. First, we're going to do samples with n equals 3, so sampling 3 people. And again, I have our population in here. So what I have are some of these labeled yes, based on however a particular student answered them, and some labeled no, okay? So we have just answers yes or no. And then we're going to draw 3 at a time to make a sample of 3. And then after that, we're going to draw 5 at a time and do a sample of 5. Okay? So just like the last one, let me just do a couple and then I will pause. The video is not so long. And see if you can guess what you think is going to happen. And also, I'm gonna ask you if you can make a guess on what you think the population proportion is. Okay, so let me mix these up. And I'm gonna choose 3. Okay, so we have no, yes, yes. Okay, so sample 1. No, yes, yes. So this time, instead of an average, because this is categorical, we're making a proportion, so we're dividing. And in this case, we're going to be counting the number of yeses, okay? So we're going to count. We could just as easily count the no's. We just have to decide one or the other, okay? So we're counting the yeses, and we're making a sample proportion, which is p hat, and this time the yeses were 2 out of 3. Okay, and that's 2/3 or 0.67. And then this time I have my scale from 0 to 1.0, meaning 0% to 100%, because those are the possible proportions we could get, right? You could get nobody born in Oregon to everybody born in Oregon, 0% to 100%. Okay, so I'm going to mark 0.67. I'm going to go to the right, so that would be to the right of the 0.6. And shade that one in, and this is proportion of the sample who were born in Oregon. Okay, I put those back in, very important, because we're starting with the same population every time. And now I'm going to pick 3 more. Let's see, they get a little stuck together sometimes. Okay, this is yes, yes, no. Okay, happen to be the same thing. yes, yes, no. So our p hat is also 2/3 or 0.67. So another one here. Okay, let me do one more before I pause it. One, two, three. Will we get something different? C, no, and no. So yes, no, no. So that is 1 out of 3 said yes. So 1/3 or 0.33. So I get to mark just to the right of the 0.3. Now you might notice because we only have 3, there's only certain values we can get. Let me go ahead and pause it and do a few more to give you an idea of what this histogram is going to look like. See if you can guess what you think it's going to look like. Okay, see you in a minute. Okay, so I went ahead and finished 10 samples, and this is what the histogram looks like. So you can see on 3 of them we got 1/3, and 7 of them we got 2/3. Okay, so from this it's kind of interesting to think, what do you think that the true proportion is? This is what we often want to know, right? It's what we're trying to estimate. What is our true proportion? Well, it looks like it's probably pretty close to here, but there may be some more, some fewer yeses. So I would guess it'd probably be somewhere in here. And we can actually estimate this, right? So we can take our average. Oops, there's an E on the end. We can take our average. I'm going to go ahead and average all these numbers together. So 0.67, I could just add them all up and divide by 10, but to do a little shortcut, I'm going to do 0.67 times 7, because I know there's 7 of those, plus 0.33 times 3, because there's 3 of those, and then I'm going to divide by 10. Little shortcut, so 0.568, okay, 0.568, oops, 0.568, so that would be a little bit over 0.55, so that would be right about here. Okay, so that would probably be a good estimate for our population proportion. Okay, now because we have our population in the bucket, we'll be able to see how close this came in a minute. Okay, but you can see the limitation, right? It's only 3 people, so we can only really get 0, 1/3, 2/3, and 3/3. Those are the only possibilities we can get. So let's do this again with a little bigger sample size and see if you can guess what's going to happen when we increase our sample size. Again, I'll do a couple of these and then I'll fast forward for you. So let's start again with 1 right here. Now I'm going to take a survey of 5 people, and we're surveying without replacement, right? Because I'm not going to ask the same person twice. I'm not putting the papers back in. 4, 5. Okay, so we've got yes, no, yes, yes, yes. I just kind of wrote them differently so we would see if we weren't getting the same yes over and over again. You can't quite see them all, but yes, there's 1 no, and then there's 4 yeses. Okay, so 4 out of 5. Yes, 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 no. So our p hat is 4 out of 5. Yeah, 4 out of 5. And fifths go 20, 40, 80, 60, 100. So this is going to be 80%, 0.8. Okay, so 80%. Okay, interesting. So we already got a little different thing than that one. Let me do one more and then I'll fast forward it. Okay, good, that's 5. So we've got yes, no, no. So I think those are 2 different no's than the other no we had last time. Yes and yes. Okay, so this time we have 3 out of 5. So 60% of the people surveyed. So yes, 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 no, no. 3 out of 5 said yes, we're born in Oregon, so that is 60% or 0.6. Okay, and this is the proportion of the sample who were born in Oregon. Okay, I'm going to pause it. Okay, here is the rest of this sample. I did 10 total out of sampling 5 people and calculating the sample proportion. So it's really interesting. It's more spread out. For one thing, there's more possibilities, right? You can get 0%, 20, 40, 60, 80, or 100%. So there's a few more options available. But it seems like maybe, you know, this was pretty skewed. It seems like maybe this is skewed to the left. Maybe this is more symmetric. I don't know. It's a very small sample size. So we can kind of make some conjectures, and then we're going to go to technology and see what happens when we do a lot more samples. Let's go ahead and do the average here. And then I want you to make a guess as to what you think the true proportion is in our sample. So this one, well, I guess I can use my histogram and do the shortcut. Here, I like that, so I'm less likely to make a mistake. So we have 0.4 times 3 plus 0.6 times 3 plus 0.8 times 3 plus we got a 1. So we actually got 1 with all 5 yeses. And then divide that by 10 comes out to 0.64. So that one came out a little bit over, a little bit to the right of that one. Okay, so let's see how good of an estimate both of these are. So I know what's actually in the bucket here. And it turns out, so for our population proportion, which we would use the letter P, P is for the population. And when it's from a sample, we put the hat on it, because statisticians have to accessorize their variables. So we're gonna write out the original population. There were 10 yeses out of 16 people who were there that day. So 10 out of 16, let's see what that comes out to be, is 0.625. Okay, so that's our true proportion. These weren't too bad, were they? We got 0.568 with one method and 0.64 using the other method. Now, keep in mind, in reality, we only take one random sample, right? We do a political poll, we take one sample of 1,500 people, say. And we don't know what the population is. So that's why we need to understand what the distribution of all the random samples looks like. Okay, so in the next video, I'm going to go to a computer simulation, online simulation, and you'll have the link available to you in D2L or in the description of the video, and I will see you there.